Hey, AP Chemistry. I wanted to do that AP problem from 1995, the one with H2CO2 in equilibrium with H2O and CO. I wanted to do letter E here. A through D are okay. I sent a picture of the answer key, but I wanted to explain how we do E and show you an example of the quadratic. So in earlier question, you were asked to determine the KC, and you should have got that the KC was about 5. If you did the math, you got KC was 5. So we're going to use that for E. And so I'm going to rewrite the equilibrium H2G plus CO2G is in equilibrium with H2O, G plus CO, G, these are all gases. And I'll do my ICE business. It says in a different experiment, 0.5 moles of H2 is mixed with 0.5 moles of CO2 in a 3-liter reaction vessel. Now, don't forget that moles divided by liters is equal to my molarity. So 0.5 divided by 3, that should be about 0.017 molar. Same thing for this one, 0.17 molar. And I should have no H2O and no CO. So don't forget to convert my moles with my liters to molarity. So that's my initial concentration, 0.17 molar. My change then, everything is 1 to 1 to 1 to 1 mole ratio. So minus X plus X plus X. And I know that products are being made because my Kc is greater than 1. So products are being formed. And then at equilibrium, it would be 0.17 minus X, 0.17 minus X, X, and X. Okay? Now, if I write my Kc expression, it should be concentration of H2O, which I can do that because it's a gas, times the concentration of CO, all over the concentration of H2 over the concentration of CO2. And this is supposed to equal 5. Now we have a problem here because we cannot do the small x approximation because my value of k is not small. So when my value of k is not small, meaning 1 and greater than 1, maybe even 0.1, I cannot use the small approximation, so I'm going to eventually have to use the quadratic. So I'm going to start putting in my values. These two are going to be x times x over 0.17 minus x, 0.17 minus x, and that's supposed to equal to 5. Now my problem here is, again, I cannot use x approximation here because I have a k that's large. This is a large K. So I have to use quadratic. Now I'm hoping you remember how to combine and do things like this, but I'll show the bottom one here and then I'll try and combine later and I'll show you my answer. Now if I have two equations like this where I have like 0.17 minus x, 0.17 minus x, this is like FOIL, if that look or sounds familiar. So I'm going to do the FOIL method, minus x, 0.17 minus x. The first terms is 0.17 times 0.17, and according to my math before, I did this before, so 0.17 times 0.17, and I get 0.0289, so 0.0289, and then minus 0.17x minus 0.17x, and then plus x squared. So you do first, or I don't know, I forget what FOIL stands for, but you do the first one, and then you do outer, and then inner, and then last. So first, outer, inner, last. So you multiply 0.17 times 0.17, and that's where I got the 0.0289. Then 0.17 times minus x, that's where I got the minus 0.17x. And then the minus x times 0.17, that's where I got the other minus 0.17x. And then minus x times minus x, minus times minus is plus, x times x is x squared. And then you combine like terms and you get 0.0289 minus 0.34x plus x squared. And that's what this denominator is. And so I'm going to put, and then x times x is x squared. So I'll get x squared all over 0.0289 minus 0.34x plus x squared. And that's supposed to equal to 5. Now I'm going to have to flip this over, but now I want to combine, again, I'm trying to rearrange and combine everything. So in order to get this x squared by itself, I have to multiply this times 5. So I'm going to bring this whole thing and multiply it times 5. So in flipping this over, I'll get x squared equals 5 times 289 minus 0.34x plus x squared. And so if I have this 5 times this, I distribute this. Now this is math heavy, and you're going to have a problem like this on your quiz where I just make you do one quadratic. And so if I do this, I'll get x squared equals 5 times 0.0289 is 0.1445. So 0.1445, 5 times 0.34 is going to be minus 0.17x. So 5 times minus 0.34 is going to be minus 1.7x. And then 5 times x squared, of course, is plus 5x squared. And now I want an expression. Remember, for quadratic, I want it to be like ax squared plus bx plus c or minus equals 0. I gotta have everything on one side. So in order for me to do that, I'm gonna have to take, so I want it to look like this. Look like this. So I'm gonna have to take this x squared and move it over here. So I'll subtract x squared from both sides, and I'll get 0 equals 0.1445 minus 1.7x plus 4x squared. And so now I have an expression that looks like this. And remember, my a is attached to my x squared, my b is attached to my x, and c is whatever doesn't have the x. So a, b, c. And if you remember the quadratic equation, which you'll see it maybe in your math classes, it will definitely be on the SAT and does help you on the SAT. So that's another reason why I'm trying to throw this on you, to have some SAT prep, because we're juniors. So you would do negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I plug in these values. A is 4. B is negative 1.7. C is 0.1445. So negative b, negative 1.7 plus or minus the square root of negative 1.7 squared minus 4. A is 4. C is 0.1445. Okay? All over 2 times 4. And so if I continue to do this again, I'll get 1.7, because I do negative times negative is positive, plus or minus the square root of, well, 1.7 squared, now it's negative 1.7. If you know negative times a negative, that's a positive, so any negative squared is positive. So negative 1.7 squared is 2.89, and 4 times 4 times 0.1445, that's equal to 2.312. 2.312. So 2.89 minus 2.312, that's equal to 0.578. So that's going to be square root of 0.578 all over 8. Right? So I did the math inside the square root. I didn't do the square root yet. And so if I do the square root of that, square root of 0.578, that's supposedly equal to 0.760. So 1.7 plus or minus the 0.760 all over 8. And now I'm going to have two roots here. The one where I add and the one where I subtract. So I'll do 1.7 plus 0.760 divided by 8. And 1.7 minus 0.760 divided by 8. If I get these two roots, I'll get 1.7 plus 0.760 divided by 8. And I get 0.3075, so x is one way, and then x could also equal to 1.7 minus 0.760 divided by 8. X could equal 0.1175. Now here is the tough part. I have to figure out which of these x's I use in this equation. Now, if you remember, I only started with 0.17, so I have to subtract x from 0.17. If I subtract x from 0.3075, what's going to happen? If I subtract 0.17 from 0.3075, I'm going to get a negative value for reactants. That's not okay. But if I subtract 0.1175, I will get positive values. So I'm going to say I need to use this root. Cannot use x equals 0.3075 because we'll get negative concentrations. I know I wrote all over this, but I'm hoping you heard that, right? If I use the 0.3075, if I plug it back into here, I'm going to get negative reactant values. That's not okay. I can't have negative matter. So I need to use x is equal to, and I'll try and do this in a different color or whatever, right? So if I say x is equal to 0.1175 now, right, so x is equal to 0.1175, equilibrium, if I say x is equal to 0.1175, I'll do 0.17 minus 0.1175, 0.17 minus 0.1175, and then x is going to be equal to 0.1175 molar. And so if I do my subtraction here, 0.17 minus 0.1175, I get that my equilibrium concentrations, if I just want to do all of them, concentration of H2 is equal to the concentration of CO2, which equals, this subtraction is 0.0525 molar. And then the concentration of H2O is equal to the concentration of CO, and that's equal to 0.1175 molar. Now with significant figures, I really only had 2 sig figs, so you want to make sure that you have 2 sig figs in the end, so 0.053 molar, 0.12 molar, if I want the correct number of significant figures. Okay? Now I'm hoping I showed you how to use the quadratic equation and the math involved for a type of question like this. You will have a question like this on your quiz. I may switch up the numbers and I may rearrange the equation a bit, but make sure you're able to do something like this where you follow through with solving for the quadratic where you want to set it equal to 0. Make sure you remember how to do FOIL where you multiply and combine like terms. Combining like terms is going to be paramount for something like this. So I had to do a FOIL here, and then I got some equation that was x squared, and then I had to combine everything to one side, and that's why I multiplied by 5 as a quick recap. And then I got an expression like this, and then I want to bring everything over to one side so it has a 0, because quadratics have to say ax squared plus bx plus c, or minus bx minus c. It has to equal 0. So that means I have to take everything away from one side and put it on the other. And so I got this expression. I plugged it into my quadratic equation here, negative b plus or minus the square root of b squared minus 4ac over 2a. And once I plugged it in, I have to figure out which root was going to be the one I use. In some cases, you'll get a negative root and a positive root. If I get a negative one, I'm obviously not using that one. If I have 2 positives, I want to use the one that does not give me an incorrect or negative value in my equilibrium expression. Alright, so I'm hoping this video helped. It's a long video. If you have any questions or concerns, you can comment on the Google Classroom or on the video itself, or message me in the Remind.